Okay, in this video I'm going to talk about second order differential equations, and we've got an example here. These examples are usually called complementary functions, but let's just see what it is. So we've got here if y equals e to the power x kx, that's by the way a k, and then kx to the power kx. He wants to find k if this was the solution for that. So we've got second derivative, which is d squared y over dx squared minus dy dx minus 6 equals to 0. This is, by the way, you can see it looks like quadratic equations. Well, we're going to find out soon. So, as usual, we try the solution. We look at y equals to e to the kx. Well, we can find the solution for that. We can differentiate it, right, in terms of x in respect to x. So if we differentiate y equals e to the power k x in respect of x, we'll get, well, dy dx, right? If we differentiate that, we'll get k, because k is just like a constant, isn't it? K to the power kx. Oops, sorry, handwriting's a bit messy. I know. So that differentiation, well, let's take a second derivative of it. I'll tell you why. So if we take a second derivative of that, we'll get, well, this would be 2 squared y over dx squared equals, take the second derivative of that, again we take the power, the constant, take derivative of the power, so it's going to be k times k, which is k squared, and then e kx. Now look, you've got this and that, and if you look at the equation, well, we can substitute d squared y over dx squared with this, right? Because they look exactly the same. It's just substitution. The same thing for this, dy dx. We can substitute with k e to the power kx. That's exactly what I'm going to do here. But let me just zoom out. I want it out of the room. The camera is running out of the room. Oh, again, sorry, I forgot about that. We can also substitute with y with what we've got in the original question, which is y equals e to the power kx. So basically, we're going to substitute every variable here. We're just going to leave the constant in the quadratic equation. So, oops, k squared ekx minus, substitute dy dx with this, so minus k, I think we're going to use another page, and then minus, don't forget your constant, 6 times e kx, and that equal to 0. Well, if you look at this, we can factorize e to the power kx, because it just involves them all on this side, right? So if you factorize this, we're going to e to the power kx, we're going to end up with k here, and then k here, and then minus 6 here, all times power kx equals to 0. Now that's just basic quadratic equations, but instead of x we've got k. That's fine. So what we're going to do here is, well, either this equal to 0, e to the power kx equals to 0, or this side is equal to 0. So if this equal to 0, all we got to do is just factorize it into a quadratic equation, right? So k times k, that would equal to 0, and then we got a minus and a plus. Well, two numbers are multiplied with 6, and the difference between them is 1. That's actually 3 and a 2. The 3 would take the minus of the middle term. So k minus 3 times k plus 2 equals to 0. Well, the solution for that is either k equals to positive 3, or k is equal to negative 2, right? Well, now if y equals to e to the power kx, and that is the solution of the differential equation, well, then k must either be 3 or minus 2. And so we therefore have two solutions. So I'm going to put that in the new page. So either y of x, but in this case because we got two solutions, I'm going to call that y1, first solution, is going to be equal e to the power, well, we substitute k with one of the values. Let's first use 3 to the power x, right? We just substituted k with 3, and now we're going to do that again with minus 2. Or either y, the second value, the second possible value, the solution for y is just equals e to the power minus 2x. So these are the linearly independent two solutions for y. But we can actually, some people do that actually, and you might be asked for that. It's just the linearly independent, and the general solution is just y in general x. It's just a summation of y1 and y2. It's just the summation of y. So y, the summation of y or whatever, is just you add that to that. So 8 times e to the power 3x, and then plus b to the power e to the power 2x, and that's the general solution. That's the solution, and that's the general solution. This is just a solution for y 1 and 2, because we've got two solutions. But if you want to combine them together, or we add a, it's just a constant, because in integration we always put c, but we've got put c for this one and this one, but we're not going to call it c, you're just going to call it a and b. So yeah, that's basically differential equations second order. And obviously, as you can see, second order is a little bit harder than first order, but as they say, everything, or almost everything in math, has a solution. So yeah.